Today, we're going to pull back the curtain on artificial intelligence. We're going to reveal the surprisingly simple, yet incredibly powerful engine that drives all the technology you use, literally every single day. So let's just get right into it.
I mean, have you ever really stopped to wonder about that? How your music app just knows and creates the perfect playlist for you? Or how Netflix suggests a movie that you actually do want to watch? It can feel a little bit like magic, right? Almost like it's reading your mind. But what if I told you it's not magic at all?
Just think about all these different technologies. You've got facial recognition that unlocks your phone, recommendation engines, the complex systems that guide self-driving cars, even those fun image filters or the chatbots that answer your questions. They all seem so wildly different from each other, but as we're about to see, they all share the exact same fundamental secret.
So in this first part, we're going to decode that secret. We're going to uncover the hidden language that actually allows machines to think. And here it is, the secret sauce. It's linear algebra. Yeah, that's right. The absolute foundation for almost all modern AI isn't some crazy futuristic code. It's a field of math that's been around for a while, and it just so happens to organize information in a brilliantly efficient way.
So, okay, how does it actually work? Well, before an AI can learn anything, it first has to see the world. And here's the thing, it doesn't see in pictures or words like we do. It sees the world in numbers. Let's take a look at how linear algebra makes sense of all those numbers.
Okay, the first key tool is something called a vector. Now don't let the name intimidate you. A vector is really just a list of numbers. That's it. For a recommendation engine, a vector could represent you. It's a list of your ratings for a bunch of different movies. It's just a single, neat package of information.
Now, what happens when you have thousands or millions of users? Well, you stack all those vectors together and you get this, a matrix. A matrix is just a big grid of numbers with rows and columns. Honestly, the best way to think about it is like a spreadsheet, but on some serious steroids, because it's capable of holding and organizing these vast amounts of data. And this makes the whole concept really tangible. What you're looking at here is a matrix of patient data. See how each row is a different person? And then each column is a different health metric? You know, age, heart rate, blood pressure, things like that. Instantly, all this complex medical info is organized into a simple, computable grid. It's so clean.
So here's the really crucial point. Matrices give AI a kind of superpower. They allow a machine to perform calculations on millions of data points, millions of patients, or millions of Netflix users, all at the same time. It's a scale of processing information that is just, well, completely beyond human capability.
Okay, so we've seen how AI organizes its data. Now for the really exciting part. Let's look at the actual math that allows an AI to learn from that data, to find the patterns, and to start making predictions. This quote just sets the stage perfectly. At the very heart of a neural network, which is kind of like the brain of an AI, is a system of linear equations. It's the mathematical process that takes in all that data we organized and begins the process of thinking. And this is the engine itself. Now this formula, it might look a little complex, but I promise you, at its core, it's just multiplication and addition. That's it. This one single operation, repeated millions and millions of times, is how a neural network actually learns. So let's break down each little part. All right, first you have X. That's your input data. So that's our patient matrix from before. Easy enough. Then you have W, the weights. Now think of these as importance knobs. The AI learns by turning these knobs up or down, figuring out that maybe, I don't know, blood pressure is way more important than age for a certain prediction. And finally, B is the bias, which is really just a little nudge to help fine-tune the final result and make it that much more accurate. So what does this equation actually do? Well, it performs something called a linear transformation. It takes an input and it transforms it into a useful output. So it can take the data of an image, for example, and rotate it. Or it can take a really complex user profile vector and transform it into a single, perfect movie recommendation. It is the mathematical engine for taking action. So let's bring this all home and see how it builds into the world all around us. We've gone from these kind of abstract concepts like vectors and matrices to this core equation. Now it's time to connect it all back to the technology we're using every single day.
Remember this list from the beginning? Well, that one core operation, just multiplying inputs by weights and adding a little bias, but done at a massive scale, is what powers all of it. Your face being recognized, your next song being chosen, a car navigating a street. It all comes down to that same elegant piece of linear algebra.
So, the next time your phone unlocks with just your face, or you discover a new favorite band on Spotify, you'll know what's happening under the hood. You're not just using a piece of technology, you are actually interacting with the elegant and incredibly powerful language of linear algebra.
You know, the underlying math might be pretty straightforward, but its applications are so profound, and they're really only just beginning. It really makes you wonder, with such an elegant and powerful foundation, what are we going to build with it next? Thanks for tuning in.